Okay, it's time for number 12. The first time I did it, I messed up. I for some reason did fourth root, and yeah, no. So let's try that again. Let's see, chapter 6. So number 12, it says a container of hot liquid is placed in a freezer that is kept at a constant temperature of 15 degrees. The initial temperature of the liquid is 170 degrees Fahrenheit. After 4 minutes, the liquid's temperature is 64 degrees. How much longer will it take for its temperature to decrease to 32? Okay, so this is a cooling problem, so we're going to use Newton's law of cooling. Remember that one? It's going to be T equals Ts plus T1 e to the kt. Now, Ts is the room of the temperature of the room you put it in. So this is constant. This never changes. Okay, this is one value and never changes. This number is the initial temperature of the whatever you put. So if you put like a glass of water in the freezer, this is the freezer and this is the temperature of the water before you put it in. And then this is the temperature after how many seconds you've left it in there. And T is the amount of time. It doesn't have to be seconds exactly, but it's the amount of time. Okay, and T is the time here too. So they give us the initial temperature, which is T1 equals 170. Oops, T1 equals 170. The temperature of the room is equal to 15 degrees. Yeah. And the temperature, so the time they give us is 4 minutes. And the temperature after that amount of time is 64 degrees, so that's 64. Okay, and then we have all of this. Now we need to find K, because we need to find the temperature after the time after 32 that I'll take to go to 32. So we need to know K for that. We need to go, just with all these, with have the e to the k t, you always want to find K. You can't not find K. Okay. I'm getting tired of that joke too, I'm sorry. So 64 equals okay, so e to the k and the t is 4. Okay, so we move that, so it's 49. I only memorize this number because I've done it so many times. 4k here. So then you divide, equals e to the 4k, and then we take the natural log of both sides to get rid of the e. 49 over 170 is 4k, and then to get k, it's going to be ln of 49 over 170 over 4. That's your k, okay? Okay. Ah, boy. Okay, so let's go over here. Now that we have our k, we can plug that into this, and we can plug in our new temperature, 32, and we can find time. Okay, so it's going to be 32, because that's your temperature, right? TT, 32 equals the temperature of the room, 15, plus 170, the starting temperature, e to the kt, which is ln of, you know what, to make things simpler, let's figure out what k is in decimal form, because that's what this test that's what the people here like to do. Now the 44 divided by 170, that's 49, oops, and then that divided by 4, so it's going to be negative 0.310, just 311. Let's do that, 311. Okay, there you go. So instead of having to write that whole gigantic mess of ln of whatever's over whatever's, you just write that. Okay, So it's negative 0.311 times t. So now we move stuff around, right? So it's subtract here is 17, I believe. Yeah, 17 equals 170 e to the negative 0.311t. So we divide as 1 over 10 equals e to the negative 0.311t. Now remember this, we need to take the natural log, right? Remember, of both sides? Natural log. And then this becomes, remember you can bring this up and the power goes outside, so it's negative ln of 10 equals negative 0.311t. So then t equals negative ln of 10 over negative 0.311, which, and then t equals to, so it's going to be negative, I'm moving over here, negative ln of 10 over my answer, oops, negative ln of 10 over second answer, so it's 7.4. So this is the time it takes from 0 seconds, 0 minutes. So from the moment it's put in, it's gonna take 7.4 minutes to go to this to this temperature, right? To which 32 degrees here. But it says how much longer. That means after 4 minutes, right? It cooled to 64. So how much longer? So how much more than 4 minutes will it take? So that's easy. You just subtract by 4. So then that gives us a new one, 3.4. And this should be our time here, minutes. Now, this answers here is, the answers are apparently 3.68. I don't know why. I haven't done anything wrong here. This is how you should do this, and this is how it would come out normally. These tests like to be wrong sometimes. But yeah, this is how you do it. It should be 3.4. Like, I'm pretty sure if you have all this work, Mr. Pearl is going to be like, okay, you did good. You know? And it's not because I rounded here, where I decided to figure out ln. Okay, actually, before I've done it with using that big number there. This whole thing too, and it still gives you the same thing. Okay, so, good. Bye.